Hello everyone. Today we're going to talk about the slope of the line. In our previous video, we introduced the linear equation into variables. And we said that the graph of the linear equation into variables is a straight line. Today we are going to talk about the slope of the line. Let's say we're given a point on the plane, and actually we could choose any point. Let's see. Okay, let's choose this one with coordinates 1, 2. I want to draw a line through this point. I could draw a line that would go like this, or I could draw a line that would go like that, or like this, or like that. Actually, I could draw infinitely many lines that go through this point. Two questions. What do these lines have in common, and what is different about them? The answer to the first question is easy. They all share the same point, 1, 2. To answer the second question, we are going to take a closer look at these lines. Let's highlight this line. You probably already recognized it is a horizontal line. And why do we decide that? Because it seems to be parallel to x-axis. Now imagine I would start rotating this line around this point. So if I rotate it to this angle, I could get to my second line. And if I rotate it to this angle, I could get to my third line. And if I rotate it to this angle, I would get to the fourth line. So these angles actually have a special name. They're called angles of inclination. And each line that goes through a given point has its own distinct angle of inclination. So going back to our second question, what is different about all these lines? They all have different angles of inclination. Okay, so let's look now at a different problem. Again, let's say we're given a point and we could choose the same one with coordinates 1, 2, but now we're going to be given an additional point and we could choose this one with coordinates 4, 3. Through these 2 points, we can draw a straight line, but now it's going to be a unique line with its own distinct angle of inclination. So now think about that. In the previous problem, when I was given 1 point, I could draw infinitely many lines. But once I was given the second point, my choices were limited to a unique line with its own distinct angle of inclination. So my conjecture is that I should be able to identify this angle of inclination using the coordinates of these 2 points. The question is how? To answer this question, let's do some exercises. Let's say we want to draw a line through the origin at 45 degrees. Now, I do know that 45-degree angle is half of a 90-degree angle. So if I want to draw the line, I should draw the line that would split my first quadrant into halves. But what I could also do is to draw a right triangle with the same vertical and horizontal side. And thus this angle is going to be a 45-degree angle. And actually it doesn't matter how exactly long the sides are going to be. I could draw this triangle for as long as the ratio of the sides of a vertical and a horizontal side is going to be equal to 1, which means the sides are going to be equal. This angle is going to be over 45 degrees. Now, let's look at another interesting example. In this triangle, where the vertical side is the half of a horizontal, this angle is equal to 30 degrees. So here's the question now. Can we use this ratio of vertical horizontal side of right triangle to identify any acute angle? And the answer is yes. So let's go back to our line. And let's see how we can use this ratio to identify the angle of inclination. So I already have a horizontal segment going from the first point right here. So what I'm going to do is to draw a vertical segment going from the second point. So this is my angle of inclination. And now this is the right triangle. Now I could clearly see that the vertical side of my triangle is equal to 1, which is actually the difference between y coordinates of my points. Now the horizontal side is equal to 3. And again, this 3 turns out to be the difference of the x coordinates of my points. So the ratio of the vertical and the horizontal sides of my triangle is equal 1/3. And that ratio I could use to identify this angle of inclination. But then we could ask ourselves, what if we have a different point, or if both points are going to be different? Well, we could, try to find another point on the line, and we could choose this one with coordinates 7, 4. We could build it up to a right triangle using the original point 1, 2, and this one. And here's our right triangle, and this one is the angle of inclination. Again, we can see that the vertical side of this triangle is equal to 2, which is again the difference of the y coordinates of my points. The horizontal side is actually equal to 6, and it's the difference of the x coordinates of the points. Now, the ratio of the vertical and the horizontal side for this triangle is going to be equal to 2/6, which reduces to 1/3. So it seems like regardless of what points I'm going to choose, the ratio of the vertical and horizontal side is going to be the same, and thus I should be able to use it to identify the angle of inclination. This ratio has a special name. It is called the tangent of the line, but here in algebra, we will refer to it as to a slope of the line. Okay, now let's summarize what we just said. Let's say we're given a point, 2 points, one with coordinates x sub 1, y sub 1, and the second one we should label as the point with coordinates with x sub 2, y sub 2. We know that through these 2 points, there will be a unique line with its own angle of inclination. And I should be able to identify this angle of inclination using the ratio or using the slope of the line that is the ratio of a vertical and a horizontal sides. Now, the vertical side, often referred as a rise, is equal to the difference of the y coordinates, y sub 2 minus y sub 1, which we could label with delta. Delta is a Greek letter used to label the difference or change in the quantity. So y sub 2 minus y sub 1 could be simply presented as delta y. And the horizontal side, often referred as a run, is equal to the difference of x coordinates of my 2 points, x sub 2 minus x sub 1. It could be just labeled as delta x. So we could say m is equal rise over run, or y sub 2 minus y sub 1 over x sub 2 minus x sub 1, or delta y over delta x. So if we want to give a quick definition of a slope, we could say that slope is the rate of the change of delta y over delta x of any 2 points on the line. But we could also say that slope is the tangent of the angle of inclination of the line. And one last thing that I want to show you today in this video is how we can use slope to graph the line given a point. And let's pick up this one with coordinates -2, -1, and the slope. And we can choose m equals 3/4. So remember, slope is the ratio of rise over run. So I could actually use the slope to find additional points. Or actually, I need one additional point to be able to graph the line. So if I'm going to start performing the steps according to my slope, meaning from this original point, rising 3 units and then running 4 units, I'm going to end up at this point with coordinates 2, 2, and that's going to be my second point that will be laying on the line. Now I have enough points to graph the line, and that's how I can use the slope to find this additional point. Actually, I could find more additional points using the slope. If I keep performing those steps, rising 3 units up and running 4 units, that I will end up again at the point on the line, and now it's going to be the point with coordinates 6, 5. One last trick. 3/4 is a positive number, which is a ratio of 2 positive numbers. But it could also be presented as a ratio of 2 negative numbers, because negative over negative is equal to positive. So actually, to find additional points, I could use now this form of the slope, -3/-4. Well, let's try it. Let's go back to our original point. And instead of rising 3 units, we're going to fall 3 units and then run to the left 4 units. And what I see, again, I'm going to end up in a point on the line, but now it's with the coordinates -6, -4. So what do we see now? If we're given a point and a slope, that's enough information for us to identify a unique line. And that's how we can use the point and the slope to graph the line. And you can graph the line, or you can find additional points that lay on the line using the slope. In our next video, we will talk about the lines with negative slope. Thank you for watching. See you in our next video.